Now I continue with the derivation of multiple angles like 3x. So far we have completed sin 2x, cos 2x, tan 2x, sin 3x, cos 3x. Now finally I want to see this tan 3x, and here I write tan 3x may be written as tan of 2x plus x. So tan of x plus y formula can be used. Tan of x plus y is tan x plus tan y, 1 minus tan x tan y. Tan x plus tan y divided by 1 minus tan x tan y means, y means x here. So once again you have to use this tan x plus tan x means here you can write the formula, you can write directly 2 tan x divided by 1 minus tan square x plus tan x divided by, here also 2 tan x divided by 1 minus tan square x into tan x. So the formula here used tan of x plus y and tan of 2x formula we used, and both nr and dr multiplied by 1 minus tan square x, easy going. So 2 tan x cancelling plus tan x into bracket 1 minus tan square x. Similarly here 1 minus tan square x plus 2 tan x into tan x, and finally you can understand 2 tan x and plus tan x and what do you say, minus tan cube x. So here you write that in the denominator, you can write that. How we can use this idea? The formula is tan square x, and how many tan square x that you have to write it. When you write this formula 1 minus tan square x, and you can write tan cube x, that is 2 tan square x, and here you can use the idea that 1 minus tan square x, 2 tan x, that is nothing but 1 minus tan square x. So here you can use that formula, that 1 minus tan square x, and you have to go for 2 tan x and is 2 tan square x minus tan square x. So 1 minus tan square x here, see this 1 minus tan square x minus 2 tan square x. So what we get is the final result, 2 tan x, this is 3 tan x minus tan cube x divided by 1 minus 3 tan square x. So this is RHS when you go for LHS if you are taking. So far we used multiple angles, and I hope you understood how tan 3x can be proved 3 tan x minus tan cube x 1 divided by 3 tan square x. So no need of proving that sec of 3x, cosec of 3x, cot of 3x. Only sin 3x, cos 3x and tan 3x. Now I am going for discussing all about the submultiple angles. So which are the submultiple angles? Generally we take x by 2 or theta by 2, and here I am discussing when the functions, how we change multiple to submultiple. There are some important submultiple angles that we discuss, and here I am proving. Actually, proving is not necessary, that we have understood. For the practice purpose, I want to take trigonometric functions of submultiple angles. So first I want to explain that cos x, second one you see this, second is sin x, and similarly you can go for tan x also. First I want to explain only sin x and cos x, that's the important part. Let us see this. First sin x only I am going to take. How you can prove the important result. So this cos x can be written as cos of 2 into x by 2. And you know the formula that accordingly you can use. What? Cos 2 theta, there are 4 formulae that we have seen. You know that cos 2x is, you take as a 2x, cos square x minus cos. So cos square x by 2 minus sin square x by 2. Now here you can see that this is cos square x by 2 minus of 1 minus cos square x by 2. What equal to sin square? What can I say? Cos square x by 2 minus 1 plus cos square x by 2. So what is the result? You can see 2 cos square x by 2 minus 1. What equal to 1 plus cos x is equal to. But remember, very important formula that I have to tell now, that cos x is equal to this. When you bring this 1 plus cos x is equal to, if you bring this 2 cos square x by 2. This is one important formula we have taken. In the same way that again I take what? Cos x is equal to this, I am going to write cos square x by 2 minus sin square x by 2. So here we have changed sin to cos. Now here I am going to set cos to sin. Cos square x by 2 means 1 minus sin square x by 2 minus sin square x by 2. What do you say this? 1 minus 2 sin square x by 2. So you bring this 2 sin square x by 2 and you take it that 1 minus cos x. So what is the formula here? 1 minus cos x is equal to 2 sin square x by 2. These are the two important formulae we use again and again. 1 plus cos x is equal to 2 cos square x. 1 minus cos x is equal to 2 sin square x. But here you can understand that how this can be used. And even I tell you that cos x may be written in terms of tan. That also you can write. So this cos x, cos 2 of x by 2. And you can see this cos square x by 2 minus sin square x by 2. So this is cos square x by 2 minus sin square x by 2 and divided by cos square x by 2 plus sin square x by 2. And dividing nr and dr by cos square x by 2, 1 minus tan square x by 2 divided by 1 plus tan square x by 2. What equal to? This is nothing but cos x is equal to. So here you understand this cos x also we understand in this case. So these are the possibilities about the cos x using the submultiple angles. So now I want to see that similarly I have to discuss with the sine function. Now this is all about cosine. Now I discuss with the sine with the submultiple angles. But in case of sine only there are 3 formulae you can see, but here we write it only 2. What? See this sin x can be written as sine of 2 into x by 2. Sin 2x is 2 sin x cos x. So here 2 sin x by 2 cos x by 2. And here you understand that basically you can write this in terms of tan. You may write what 2 sin x by 2 cos x by 2 divided by cos square x by 2 plus sin square x by 2. So dividing nr dr by what? Cos x by 2. Cos square x by 2 if you take. Cos square x by 2 means here 1 is 2 tan x by 2 divided by 1 plus tan square x by 2. So this is the case with result when you are writing that 2 tan x by 2 divided by 1 plus tan square x by 2. Now similarly we go for with tan function, because you know the formula tan what? See, this third one is tan x. So tan x may be written as tan of 2 into x by 2. What is this? 2 tan x by 2 divided by 1 plus tan square x by 2. So here that we have understood that how we go for writing the functions in terms of x by 2, sometimes theta by 2. These are called submultiple angles of trigonometric functions. This is the end of multiple and submultiple, and finally we have to discuss only one part left out in this topic, that is called transformation formulae. Transformation formulae, I mean product to sum or sum to product. First I want to give some formulae, sum to product, and at last I see that product to term. So what is the heading here? Transformation formulae. Transformation formulae, you can see that are in some books product formulae they tell sum to, and first theorem, and I have very important that is sum to product. I am writing sum to product. First I write the formula, then I have to prove how we get all these things, and accordingly we have to see the result. First one I have to write that cos x plus cos y, and second one is cos x minus cos y, third one is sin x plus sin y, and fourth one is sin x minus sin y. So 4 formulae that can be proved here, and accordingly you have to see the results. So now to remember the RHS, and I tell you how to write the result here. So first you have to remember this shortcut method. I am going to explain that. C plus C, that is 2SC, C minus C 2CS, S plus S, and here you have to write that particularly S plus S is 2CC, S minus S is minus 2SS. So these are the formulae that you can use it, and accordingly you can write the results here. So first you have to go for using the formula how you write the result, S plus S, and here you have to see that S plus S, or it is a little bit confusing if you say that first S plus S and then finally we can see this. Even that way also we can write what? First one is what? Sin x plus sin y, number 1, sin x minus sin y, number 3, cos x plus cos y, and number 4, cos x minus cos y. So here what you have to remember that particularly when you see that result, and here we have to change the structures, and what you have to go for? S plus S, S minus S, C plus C, C minus C. So these four are to be remembered. That is called, you have to see this. Already I have told you, this is 2 SC, 2 CS, 2 CC minus 2 SS. So these are to be remembered. It is easy going. So accordingly that 2 SC means what? 2 sine of x plus y by 2, next cos of x plus y by 2, and this is 2 cos x by 2 and sine of x minus y by 2. And here you see that the next one is c plus c, that is 2cc, 2 cos of x plus y by 2, cos of into x minus y by 2, and that is minus 2 ss. S means what? 2 sine x plus y by 2 into sine of x minus y by 2. So these formulas are to be proved. First sine, cos. Remember SC, CS, CC, SS. So this is the way how to remember. This shortcut method is to be followed. Now I have to prove these results, that how we go for writing all these results. So first of all you have to see the results, and accordingly we can write the things here. Only two formulae that are to be used. See that? And even I am explaining how we find this, how we derive this sum to product formula. Look this, very interesting and not important to prove the result in the exam. First you should follow it. And sine of a plus b. Of course we have proved sine of x plus y. In order to avoid the confusion, and I am going to take sine of a plus b. What is sine of a plus b? Sine a cos b plus cos a sine b. And what is sine of a minus b? And you know this is sine a cos b minus cos a sine b. So this is equation number 1 and this is equation number 2. But when you write it this, that equation number 1 and 2, add and subtract. See, adding and subtracting. See this, 1 and 2. First I should add, and you see that sine of we get here. See this, we get sine of a plus b and plus sine of a minus b. This is equal to, adding means cos a sin b, cos a, it is cancelling. 2 sin a cos b we find, 2 sin a cos b you find it. This is equation number 3. Sine of a plus b, sine of a minus b, 2 sin a cos b you have got. And subtracting sine of a plus b minus sine of a minus b, you have to subtract, these two are cancelled, and ultimately you will see that 2 cos a sin b will find, 2 cos a sin b. It is equation number 4. Now again we have to go for 3 more formulae. Now what? See this, cos of a plus b. Cos of a plus b is what? Cos a cos b minus sin a sin b. This is equation number 5. And cos of a minus b is equal to cos a cos b plus sin a sin b. This is 6. Adding and subtracting, which are 5 and 6. What we get? Cos of a plus b plus cos of a minus b is equal to, adding what we have got, these are two are cancelled. So 2 cos a cos b we find, 2 cos a cos b find, this is 7. And subtracting what we find, you see, cos of a plus b minus cos of a minus b, subtracting this 5 and 6, cos of a plus, and you have to see this when you are subtracting. So what result we will find? This will be minus and this will be plus. And here you understand that which are cancelling, which are remaining here. What I say that this minus this, cos a cos b plus sin a sin b minus cos a cos b plus sin a sin b, but cos, and here cos a cos b is cancelling, and minus minus plus here, what we understand here, see that cos a cos b sin a sin b minus sin b, here minus cos a cos b minus, so how many? Minus 2 times sin a sin b, we got it. This is number 8. So subtracting, what you say, this minus this is 0, this is minus, both are minus, 2 sin a sin b. So how many equations you have got? 8 equations, that according to the result here. And I hope that when you are understanding all these things, that according to the simplification order, you will get it cos of 2 minus 2 sin a sin b, and other one is 2 cos a cos b. Now see, let us see that what will be the new results, how you find this. Now I say that what the value of x and y you have to find out here. We want to change the value of a and b. See, suppose if we say a plus b is equal to x and a minus b is equal to y. We want to bring out in terms of x and y. When you go for a plus b is equal to x and a minus b is equal to y, then accordingly you have to find out how you get it. But here when you see that a plus b, a minus b is equal to y, what is the value of x? To find the value of x, to find, see, I am writing for clarity, to find x and y, or you can see that solving these we find x and y. How to find out? Solving means either to be add or subtract. A plus b equal to x, a minus b is equal to y. Suppose if you add b, we cancel. 2a is equal to x plus y, and ultimately a is equal to x plus y. To find what you say, solving these equations, you find a and b, not x and y. Now you see that directly put, or you have to subtract that, we can see that now a plus b is equal to x, a minus b is equal to y. Now this time you subtract minus, minus, minus. So here you will see that how you find out the result. So this is cancelled, and 2b is equal to x minus y. So b is equal to x minus y by 2. So these two values you have got. Now put from what? 3, 4 and 7 and 8. 7, 8 we get. These values we have to put it in what? 3, 4, 3, 4 and 7, 8 equations. Now you see this. Sin C means a plus b is equal to what you have taken? X sin x plus sin y is equal to 2 sin. A means x plus y by 2, b means x minus y by 2. This is one formula, you got it. Now you see that fourth one, sin x minus sin y, that equal to 2 sin cos x plus y by 2 and sin x minus y by 2. And now you see this 7 and 8. cos c, not c, cos x plus cos y, that equal to 2 cos a means x plus y by 2 cos x minus y by 2, and finally cos x minus cos y minus 2 sin x plus y by 2 into sin x minus y by 2. So here you have got this formulae, whatever we are planning to derive. So here you understand that direct way, s plus s is equal to 2sc, s minus s is equal to 2cs, c plus c is equal to 2cc, c minus c is equal to minus 2ss. So these formulae have to be remembered to write the results. This is the way how you have got the formulae, what do we call that, product to sum, no, sum to product. Now I am going to see that product to sum. Once again, I hope these 4 formulae, 1, 2, 3, 4 are to be remembered. These are called transformation formulae that are transforming sum to product. Now I want to see that finally second theorem, product to sum. How you prove? That is again repetition, but here I have to go for separately how that can be taken. Now in general we see that formulae that sum to product is more comparatively product to sum. Anyhow, I have to prove both here under theorem 2. See what is theorem 2, I am going to explain here. Number A, 2 sin x cos y is equal to sin of x plus y plus sin of x minus y, and B, 2 cos x cos y sin y you write, and this is sin of x plus y minus sin of x minus y. Number 3, 2 cos x cos y, this is cos of x plus y and plus cos of x minus y. Number D, I am going to write that 2 sin x, what do you say, sin y is equal to, you have to write that according to the formula, minus 2 sin x plus y, and here you have to write 2 sin means you will get it the cos, that you can write minus, you see this cos of x plus y, what you say this, and when you go for writing this subtraction you will see this minus. So here it is easy to write that cos of x minus y minus cos of x plus y, and here I am writing that y. So this can be written, or otherwise it may be written minus 2 sin x sin y may be taken as cos of x plus y minus cos of x minus y. Either you take this or this, both are same, and here minus is there, here plus is there, it is one and the same. Now here I have to write the results, how we get all this. Now here very simple, that already we have done it, but even then for remembering once again I prove the results. These results we have got it in the first derivation, but as a matter of practice that I am going to write it. So when you see all these results, and you can find out the exact things here. Now here that adding, subtracting, something I told you, the same way we can proceed, and I have to write the derivation. So sine of x plus y, sine of x minus y. In the right hand side you have to see this. Then what adding, you will get the same result, RHS to LHS. So accordingly we can tell the results here, and that is the case. So shall I go for taking this RHS? 1 minute just for your reference. Sine of x plus y, what do you say, plus sine of x minus y. So RHS is what? 2 sin x. RHS is equal to LHS, we have to prove, So what is the formula here? Sin x cos y plus cos x sin y plus sin x cos y minus cos x sin y. So my cos x sin y, cos x, then what is the result? 2 sin x cos y, and that is nothing but RHS. So first one is the result. This A is over. Now B I want to prove like this. What is B? Sine of x plus y, RHS. What? Sine of x plus y minus sine of x minus y. What comes, you see? Sin x cos y plus cos x sin y minus sine of x minus y is what? You keep it in the bracket outside. Sin x cos y minus cos x sin y. So when you open the bracket here, sin x cos y plus cos x sin y minus sin x cos y and plus cos x sin y. So which are the term cancelling? Sin x cos y, and here remaining that 2 cos x and sin y. And what is this? This is LHS. 2 cos x sin y. So 2 cos. So first these two are completed. Now I go for that here C and D I have to do this. I hope you understood how simple way that I have proved it. Now I am going to see that last two, how we prove the results here. Now at last I want to tell you that very similar manner that can be proved, and that is easy for your reference. But anyhow, that is the last part that we can discuss, and accordingly you can continue. Now shall I take A, B, C I want to take, RHS I want to take. RHS is what? Cos of x plus y plus cos of x minus y. What is this? Cos x cos y and minus sin x sin y plus cos x cos y and plus formula sin x sin y. So sin x sin y is cancelled. Then what we have got? This is 2 cos x cos y, you have got it. And this is LHS. 2 cos x cos y is there. Now I want to tell you about D. See what is D? Cos of x minus y minus cos of x plus y. Now here you see this result. This is nothing but what? RHS. RHS is equal. What is the formula here? See, this is RHS. What? D. What is the formula? Cos x cos y plus sin x sin y and minus here the formula cos of cos x cos y minus sin x sin y. And here you understand that cos x cos y plus sin x sin y minus cos x cos y plus sin x sin y. cos x is cancelled. What result you have got? 2 sin x sin y. So this is LHS. Now here you take it, this last one if you take, how we find this result. So, or I want to take it here. Of course, it is one and the same, but you should confirm, for that sake I am going to take R. What is RHS? RHS is what? Cos of x plus y, cos of x plus y minus cos of x minus y. Yes, what is this? RHS. Cos x, cos y minus sin x, sin y minus into bracket cos x, cos y plus sin x, sin y. Now you open the bracket. Cos x, cos y minus sin x, sin y minus cos x, cos y minus sin x, sin y. So cos x, cos y is cancelled. What is the remaining here? Minus 2 sin x, sin y. What is this? LHS. That is there. LHS. This is the way how we have proved the results in this case. And more in general, I tell you, these transformation formulae that we have proved, sum to product and product to sum. This is the end of transformation formulae. Now I have to see the problems on this. Now let us go for finding the results in this case, and accordingly we can prove the things here. Now more in general, when I go for using this idea, only the problems, nearly 20-30 problems that we have to see. Today possibly I try to complete the problems here, and accordingly we can see the results. Now the point is that how we show, but only thing is that you have to perfect, you have to be thorough with the formulae, then only you can do the problems here. So I have to see that problems, and that too number 1. The question is, prove that 3 sin pi by 6 sec pi by 3 minus 4 sin 5 pi by 6 cot pi by 4 that equals to 1. Once again, sin pi by 3 sin pi by 6 sec pi by 3 minus 4 sin 5 by 6 and cot pi by 4. That is to be proved. Look here how to prove. The solution I am taking, that I have to write LHS 3 sin pi by 6 sec pi by 3 4 sin pi by 6 cot pi by 4. Look how to write it. 3 pi by 6 means sin 30. Sin 30 value is 1 upon 2. And sec means 1 upon cos. Cos pi by 3. Cos 60 is 1 upon 2. 1 upon 2, it is nothing but 2 upon 1. 2 minus. Here you have to see this sign, here into is there. And now we go for 4 sin. This is 5 minus pi by 6. Its second quadrant is sin is positive. So we have to say 6 pi minus pi by 6. And cot pi by 4. Tan 45 and cot 45 is also 1. So this is 3 minus 4. This is sin of 1 is sin pi by 6. And 3 minus 4. And try to understand sin 30. Sin 30 is 1 upon 2. So that 3 minus 2. So this is 1. And here you have got the answer is 1, that is RHS. This is the way how we simplify the results here. But you must be thorough with the well-known angles, allied angles, and even how to change it to the simplest form of these things. Now first problem is over. Now I say that second problem I am going to say how this can be proved. So only this practice you can go for it. Question is, find the value of sine 15 degree. So sine 15 degree you have to find out. So sine 15 we have to convert into the well-known angles. Sine 15 degree is nothing but sine 45 minus 30. 45 minus 30 means 15. Now you have to use the formula sin x minus y and a minus b. Sin x cos y, x means here, this is x and y. Try to understand. Sin x cos y 30 minus cos x sin y 30. So you have to substitute the values. Sin 45 1 upon 2 root 2, cos 30 is root 3 by 2, and minus 1 upon root 2, cos 45 sin 30 is 1 upon 2. LCM is 2 root 2, and here it comes 3 minus 1. So root 3 minus 1 is the answer. Root 3 minus 1 divided by 2 root 2 is the answer. This is the way how we find sine 15 degree. So generally 75, 105 can be done like this only. 75, 105. And you see this other results can be split. This is 45 plus 30, this is 60 plus 45. This is the way how you can split to find out the result. Now I am going to see the third problem, how to simplify this. See the third problem. Find the value of tan of 13 pi by 12. 13 pi by 12 we have to go for it, and accordingly you have to see the result. See now 13 pi by 12, look this, 13 pi by 12, pi by 12 means 15 degree. 13 pi by 12 we can go for the allied angles. Tan of this is minus 12 by 2. So here tan is repeated interval of pi. That is why you can write it how this can be written, 13 pi by 12. So what comes? 13 pi by 12. So repeats tan and cot repeats after an interval of pi, whereas sin cos repeat after an interval of 2 pi. So this is tan of pi by 12, answer you have got. So this pi by 12 can be split out to see the right answer, and how you can split out that pi by 12, and accordingly you can proceed the result. So you have to go for either 30, 60. So you can go for tan of pi by 4 minus pi by 6. Look this, pi by 4, why I am taking pi by 4 minus pi by 6? What is LCM is? LCM is 4 and 6 LCM. How you take? 2 to the 2, 3 to the 2 to the 4, 4 3 to the 12. And 4 3 is and 6 2 is. So 3 pi minus 2 pi. And what is pi by 12 only? You got it. So this is the way how you are now tan of a minus b you have to write. Tan of a, tan a, and here you have to write minus tan b, tan x minus tan y. So 1 divided by 1 plus here tan pi by 4 tan pi by 6. Now this is equal to tan 45 is 1, and tan 30 here, tan 60, tan 30 is 1 by root 3, and here 1 plus and 1 by root 3. Multiply NR divided by root 3. root 3 minus 1, root 3 plus 1. So here you have got the idea, root 3 plus 1 and root 3 minus 1, root 3 plus 1. Even you go for further simplification, you can go. How you can go for further simplification? This root 3 minus 1 divided by root 3, conjugate of this root 3 minus 1 divided by root 3 minus 1. So root 3 minus 1 whole square and a square means 3 minus 1. 3 minus 2 root 3 plus 1 divided by 2. See this 3 plus 1 is how much? 4 minus 2 root 3 divided by 2. What is common? 2. If you say 2 minus root 3 divided by 2, 2 to cancel. What is the result you have got? 2 minus root 3 you have got. The simplification, the maximum simplification that you have got 2 minus root 3. This is the way how we simplify the results. Next, fourth problem I am going to say now. That is very interesting problem, and only that when you know the identities very perfectly, then only you can do all this. Next problem, I have to see that result here, and accordingly you can see that number is 4. What? Prove that. What is the result? Question is sine of x plus y divided by sine of x minus y, that equal to tan x plus tan y divided by tan x minus tan y. See this, how this can be proved, and accordingly you have to go for it. So sine can be taken here. Now see the result solution, that is LHS, that comes sine of x plus y divided by sine of x minus y. So you see sine x cos y plus cos x sine y, expansion. Here sine x cos y minus sine x cos x sine y. Dividing numerator and denominator by cos x. Cos x cos y you have to find out. You have to see that cos y, you have to go for it. So accordingly you can see the result. When you divide NR and DR, you have to go for dividing by that cos y. Cos y, you have to take cos y sin y. So when you see this tan x, and we are dividing by sin x, and sin x cos y. So anyhow you have to go for dividing the result here. How we see this? I say that dividing NR dr by divide NR and dr by what do you say, cos x cos y, if you say. Just to see, cos x cos y equals sin x by cos x, we get it tan x, plus when you go for cos x cancel, sin by cos y, you got it tan y. So similarly you go for cancelling cos y, sin x by, here you get it tan x, minus cos x is cancelled, here you have got tan y. So what is this? This is the result. So this is the way how we prove these results taking LHS to RHS. Now I am going to take it that next problem, fifth one. You see how this can be simplified. But almost all these results depending on that sum and difference of trigonometrical functions, multiple and submultiple, allied angles, and also transformation formulae. Now you see the problem number 5, how this can be proved. Very interesting problem. I am going to write it here. Show that, what do you say, tan 3x, look, this very interesting, tan 2x and tan x, this is equal to tan 3x minus tan 2x minus tan x. So here you have to tell the result that, see, tan 3x, tan 2x, but product equal to difference you have got. It's a wonder, Usually we are not believing that ABC is equal to A minus B minus. It is impossible. But here it is possible. How it is possible, that I want to show you here using trigonometrical identities. Now I want to write that tan 3x is equal to tan of 2x plus x. So tan 3x can be written as tan 2x plus x, and here you can understand that result that can be proved. What we can prove here? Tan of x plus y divided by tan x tan y. So tan of x plus y, see, tan of x, tan x plus tan y, tan 2x plus tan x divided by 1 minus tan x tan y. So this is the result. Now you can take it to the cross multiplication, that tan 3x into bracket 1 minus tan 2x tan x is equal to, see, cross multiplication I have taken. So what I write here? Tan 2x plus tan x. Multiply, then what you see here? Tan 3x minus tan 3x tan 2x tan x. This is equal to, you can write the result that tan 2x plus tan x. What I do, this and this I bring that, and you take it to that side. What comes, you see? Tan 3x minus tan 2x minus tan x. So you take it to that side. That is tan 3x, tan 2x and tan x. This is the wonder result that you have got it here. Now finally one more problem I am going to take, that is the sixth one, how this can be proved. Basically, that so far we have used only that sum and difference, but now I am going to use the formula, transformation formula I am using. Look this, how this can be proved using the transformation formula. So let us see that problem number 6, how you can consider this. So problem 6 is, prove that cos of pi by 4 plus x plus cos of pi by 4 minus x is equal to root 2 cos x. So try to understand how this can be proved, the result here. Now using that transformation formula, LHS is what? Cos of pi by 4 plus x plus cos of pi by 4 minus x. The formula I told you, C plus C. Well, what already told? C plus C is 2s formula is there. So 2s sine of pi by 4 plus x, and here plus pi by 4 minus x divided by 2, and sine of pi by 4, look this, plus x, and minus pi by 4 plus x. So what comes here? You see that plus x minus x is cancelled. 2 sine of you see 2 pi by 4 divided by 2 into sine of what cancelling here? Pi by 4, it is nothing but here also you have to write divided by 2. So 2x divided by 2. Now you can see that result here, 2 sine, and 2 ones are 2 2s are, so sine pi by 2 divided by 2 here, and into sine x, and try to understand how you can prove this result, and how you have to tell that sine 90 you can go for it. This is 2 sine 2 into pi by 4 into sine x. So 2 ones are 2 2s are. What we find? 2 sine pi by 2 into sine x. And here you have to tell that root 2 how you have got it. That is the case here. And what is the answer here? Root 2 cos x. And here where how things going wrong, that you can understand. The formula it says c plus c is not 2ss, it is 2cc. The thing is that here also cos, and 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 here also cos x. And try to understand that if you got cos pi by 2, and that is also the thing you can follow easily. Pi by 4 plus pi by 4, and when you are cancelling that 2 cos pi by 4, 2 cos pi by 4, you have got it. And here one thing it is true that how we have to prove the result here, and accordingly we can write it. When you write c plus c is, and 2 cos c plus d by 2, and accordingly you have to write 2 cos pi by 4. And where that thing is going wrong, that I have to see it once again, because we have to go for cos pi by 4 where it is possible, and how you take it, and that I have to explain once again. Cos c plus c here, what I have to tell? 2 cos pi by 4 plus x plus pi by 4 minus x, and here cos of pi by 4 plus x minus pi by 4 plus x, and here c plus d by 2, and here c plus d by 2. And the question is that 2 cos, and what are the terms cancelling here? The cancel is x cancelling. 2 pi by 4 divided by 2. 2 pi by 4 divided by 2. And here you see this, what terms are cancelling? 2x by 2. So 2 cos, if you go for cancelling this, and we'll see this cos pi by 4. And when you see this cos pi by 4, this is nothing but cos x. So 2 cos pi by 4 is what? Cos 45, that is 1 upon root 2 cos x. But here 2 can be written as root 2 into root 2 into 1 upon root 2 cos x. So cancelling, you have to write root 2 cos x. So this is the way how we prove the results in general using transformation formula. Try to understand pi by 2 divided by 2. 2 is cancelled. We will get it cos pi by 4. Now I have to see that last one more problem using the transformation formula. At last I am going to consider this. So the point is that if you use the wrong formula, then you cannot prove the results. Very perfect with the transformation formula. One more problem I want to take using this transformation formula, and that completes this end of this session. Now see this problem number 7 I am going to take here, and totally see this, prove that cos 7x plus cos 5x divided by sin 7x minus sin 5x is equal to cot x. So how you can prove this cot x? Using the transformation formula. Look, this very interesting, easy. If you know the formula, cos of 7x plus cos x divided by cos of 7x sin of 7x and sin 5x. So the formula c plus c formula, s minus s formula. So c plus c means 2cc, s minus s is 2cs. What you say? 2cs. Now accordingly, the 2 cos of 7x plus x 8x by means 4x into cos 7x minus x is 6x by 2 means 3x divided by 2 cos of 7 plus 5 12 means cos of 6x. 6 what do you say? 7 plus 12, that is cos 6x. And next what? Sin of 7 minus 5 is how much? 4 means it is nothing but, and here you understand that cos 7x plus 8x divided by 2. Here you can see this, here also 7x, 7 here 5x, here 5x is there, the mistake that we have done. So look this, what is 2 cos 7 plus 5 is 12. 12 by 2 means 6x into cos 7 minus 5 is 2. 2 means cos x divided by this is, and 2 sin 7 plus 5 means what? That is here c is there, cos 12 means 6x, and next what? Sin 7 minus 5 means 12. 7 minus 5, that you have to see that only the result is 2. 2 by 2x is x. So cancelling, and here is also cancelling. So cos x by sin x is cot x, and this is RHS. So here use the formula properly, that you can find the results easily. And I am giving you one homework that can be followed at last. What is that homework? You say 8. What is this? Prove that sin 5x 2 sin 3x plus sin x divided by cos 5x minus cos x, that is equal to, you see that tan x, and you can find out how it is possible. Once again, sin 5x minus 2 sin 3x plus sin x, cos 5x minus cos x. So this I prove it, that result is tan x, and that is the end of these problems, and that is the end of this topic also. Now you see, solution LHS. What is LHS? Sin 5x 2 sin 3x plus sin x divided by cos 5x minus cos x. So this can be written as sin 5x plus sin x minus 2 sin 3x divided by cos 5x minus cos x. This is equal to s plus s. Formula you remember. S plus s is equal to SC. Then what? 2 s sin of 5x is 4x, 4x means 2x. And next cos, what is 5 minus x? 4, 4 means 2x, minus 2 sin 3x, sin 3x, 2 sin 3x, and accordingly you can write the result here. And when you see this result, 2a plus b, that is 6, 6 by 2 means it becomes 3, and cos means then you have to tell that 5 minus is 2x, minus 2 sin 3x divided by, and c minus c, c minus c you have to write. C minus c means 2ss. What is this? Minus 2s, and you see 5 plus 4, 6, 6 means sin 3x, and next s, and 3 minus 2, 1, 3 minus 2, what do you say? Here 5 plus 1, 6, 5 minus 4, it is nothing but 2x, and here you have to see this, what is common in the numerator? Numerator is 2 sin 3x, 2 sin 3x is common, you take cos 2x minus 1, here minus 2 sin 3x into sin 2x, so 2 sin 3x is cancelling, and here you understand that 1 minus cos 2x, how you get it, the result 1 minus cos 2x. So if you write this result, that if I take minus out, 1 minus cos 2x divided by minus sin 2x, so minus minus plus you write it, what is 1 minus cos 2x divided by sin 2x. Try to understand that 1 minus cos 2x is what? 1 minus cos 2x, and you already proved that 1 minus cos 2x, that you see that 2 sin square x cos square x, so you try to understand that 1 minus cos 2x, cos 2x is equal to, you know, 1 minus 2 sin square x, and 1 minus cos 2 is 2 sin square x, that you can write, what you say, 2 sin square x, this formula is there, 2 sin square x formula, and here 2 sin x cos x, 2 cos sin x, 2 to cancel, and sin x by cos x, that you have got tan x, and this is this is the end of the session, and here I have completed 8 problems. These 8 problems are solved in the textbook. In the next class, nearly 25 problems are there, out of which I want to solve 50%, and 50% you try, but I send you the notes today, what all worked part. Thank you.